this stream will just work. And we will talk about scripting mostly. So ideally, what we're going to want you to walk away with here, and to make the screen bigger, I will share that with you so you can actually see stuff, is scripting. And I probably shouldn't have killed all my virtual machines. I'll definitely need access to the internet, and I'll definitely need access to Windows 10 here. Those will come in handy. But what we want you to walk away with is a understanding of a basic, like how to identify the kind of scripts you will see out there on the interwebs. So a basic understanding of the file formats that you'll see out there, the elements you'll see inside of most scripts, how to deal with variables, how to deal with strings, how to take input, how to take output, or how to deal with output, and then be able to compare the things that scripts, and I mean ultimately programs, I don't really know as anybody's given me a great definition of script, although we'll try. Most scripting languages are really like legit Turing complete programming languages under the hood. They just don't require compilation, I think is generally where we draw that line. But we can go through and we'll talk about how to do comparisons, ifs and greater than, less than kind of stuff, how to turn those into conditional statements, and then the real superpower of computing, which is to throw things into loops and have them, iterate over a thing. And maybe even talk about recursion, because who wants to talk about programming and not talk about recursion? But hopefully, at your time at our fine institution, you will at least take our CIS 116 class, our Intro to Programming, or our Programming for Non-Programmers class, which we teach in Python these days, and will give you a good solid foundation of not really so much focused on computer science principles like algorithmic design and stuff like that, but basically how to make code do what you want it to do. Automating the boring stuff, that sort of thing, as opposed to big O notation and algorithmic efficiencies. Not that those things aren't important, but not the main focus of getting work done with code, especially in the context of pen testing. So we needed we need some kind of definition of what we're going to talk about when we're calling it a scripting language. This isn't official, but anything that is sort of running inside of a limited environment. So the two GitHub repositories we decided to look at. Let me see where I put those. Those are discussions. I can close that. Those are announcements. I can close that. These guys. So this is Average Security Guys, collection of tools. And this is Lee Baird's list of tools here. And his licensing and all that fun stuff. These will all run basically on a system with minimal muss and fuss, right? Anything that's a .sh usually means a shell script of some sort, and here you see that this one is bash. That starts by clearing up and running an fbanner here, and et cetera, et cetera. So they run in a limited environment. You don't have to compile them into an executable. If you've ever taken a slightly lower level language than a Python or a Ruby or something that is, or a JavaScript that is a interpreted language, you've probably seen that. And frequently, these are going to be used for quick little get the job done sort of chores. You need to create something that happens on a regular schedule. So you make a bash shell script and a cron job to kick that shell script off on a regular basis. I like saying shell script over and over again. It's a little bit like saying she sells seashells on the seashore. You need to memorize the rest of that too. The rest of it's cute. So there are, you know, high-level programming languages. When we talk about high-level, fun to debate computer scientists where exactly high-level and low-level breaks off. But generally, when we're talking about high-level, you're not writing x86 assembly language. Although I have heard people say, like, anything other than machine code is high-level. But generally, what we're trying to do is abstract away the hardware. And on x86 machine code, you will be like reading the Intel x86 manual in order to write that stuff and read that stuff probably. So generally speaking, we want to be higher up in the stack than that. I would argue that from a security practitioner's perspective, too much code is written at too low a level too much of the time. So people are frequently using C or low-level languages that give them control over memory that they probably don't know what they're doing with all the time, or certainly aren't willing to put in the effort to understand what they're doing with, and probably could have benefited from using a higher-level language. Like, that's one of the real popularities behind Go, is that it's supposed to be a safer language, even if you are sort of doing the traditional developer thing of rushing to get features installed into your code and not really focusing on security. But a higher level language would be something like JavaScript, which is what we mean when we say client-side code inside of a web application. So JavaScript is like a complete legit programming language, even though it's sometimes called scripting. Python, for sure, is a complete legit programming language. PHP, the personal homepage, is what it used to be called. They have since changed that. Is a complete programming language for sure. So in order to differentiate those, I guess, it's tough to know where to draw the line. But so usually when we're talking about shell scripting, that's for sure a script. Or if we're talking about Windows batch file scripting, those kind of things are definitely very simple, but certainly easy to use to like automate a task. So where exactly ScriptKitty and CodeMonkey divides, anybody's guess, but it's in there somewhere. So you should definitely recognize all of these. If you see a file that has one of these in there, you should probably know how to deal with it. You know, Windows batch files are everywhere in Windows land, less popular than they once were because of the rising popularity of Windows PowerShell, which does much the same things, although has security built into it. The Linux.sh, we just looked at a handful of those, is going to run inside of Bash, or I guess ZSH is the new hotness on Macs these days, but any Unix-like operating system. Python and Ruby, both of which we've taught at various times in our Intro to Programming class. Because of the sort of ease of use of the syntax. I tend to prefer Python because it enforces writing cleaner code in terms of, you know, how you do your indenting and whatnot. It's actually part of the language, so it makes for easier to read code, certainly on the part of the instructor trying to grade your stuff, but also you, the user of code, you will read code a whole lot more than you will write code, no matter where you wind up in the industry. Even if your day job is programming, you're going to be reading a lot more code than you're going to be writing ultimately. So keeping it clean is important. And I think Python enforces that. Ruby, though, is generally how people are writing like Metasploit plugins. So another thing you should at least be familiar with. Our friend VBScript, VBS documents, the plague of the internet for a while there. Again, you should be able to recognize them, and JavaScript and PHP also scripting for sure. Pretty high-level programming languages at this point. You can do just about everything you would ever want to do with a programming language with either of those. And in fact, the college teaches a class on both. So if you want to learn all about how to create horrible JavaScript, I'm kidding, it's not that horrible, or PHP, our two web apps classes focus on both of those. So let's break down those. The cmd.exe, which hopefully you're familiar with if you've had assignments where you had to ping things, and usually the way I get there is by firing up cmd.exe, is the command line interpreter inside of Windows. So it's It's how you get to the fun black box with the white text and the blinking cursor in Windows land. I usually Windows R CMD and have Microsoft Windows run it for me. Always useful. So basically it goes through and will accept commands, also sometimes called statements. One of these days I will stop doing that. So commands or statements that accept arguments in, like, if you've done a little programming the same way you pass arguments or sometimes parameters to function calls or libraries that you import into the functions that they bring you. Usually you can find out what those are by doing, in Windows, the / to get a handle on what it is that's in there. Sometimes, nope. That would be the Linuxy syntax for doing much the same thing. So sometimes if you just want a script that, you know, writes out a list of directories on a regular basis, you can get away with doing that. Usually you need more than that in your life. Usually you want something that's going to involve changing data. So in order to handle changing data, you will want access to variables. And if, just like in algebra class, a variable is just some placeholder for a value. And some sort of flow control where we can control what the script does bit by bit, piece by piece, as opposed to just having it go from, you know, if you learned BASIC way back in the day, you know, they would start with line 10 and then it'd do line 20, 30, 40, 50, go to 10 maybe. And that go to 10 is where you get into flow control, right? We've sent the program's flow from line 50, we've sent it back to line 10. Some sort of evaluation. If this thing is true, then do that thing kind of stuff, where scripting becomes useful. Functions, which I guess I mentioned but didn't bother to explain, are blocks of code that you're going to want to use over and over again. So you write a function once, and you can invoke it later on as time goes by. And a good rule of thumb, if you're programming or building a script, is that if you have done a thing twice, it's probably time to write a function for it. So if you've copied and pasted your code from up above into some new place because you want to do that thing again, it's time to break that out and put it into a function. Conditional statements are things that may or may not, depending on some parameter, you know, whether or not 1 is equal to, or, you know, A is equal to 1 or A is equal to 0, do this, that, or the other thing. So you've got some sort of logic there that's being evaluated. Did we get a directory list out of this program? If yes, then do something on all of the files. If no, then leave it alone. So being able to do that is what makes programming useful. And then the other thing that is the superpower of programming is that computers are willing to do the same thing over and over and over and over again, which humans are not. So building loops, which can iterate over, I had mentioned getting a directory list, you can use a loop to iterate over each file in the directory and keep looking at files until we run out of files. You know, while files or for number of files equals 1 to the number of files, do this, do this, do this. And when we meet our condition, we stop our loop and we go on. What do we call it when our loop goes on infinitely?
Infinite loop.
That's a good name for it too, right?
Memory leak?
Sometimes, although there are like legitimate use cases for infinite loops. If you want some process to keep, you know, sitting there and checking to see if something happens, or if you've got, there's a lot of infinite looping that goes on in things like GUI-based interactions, and you've got some kind of thing that's watching a button. So like there are legitimate reasons you would want an infinite loop. A menu system that loops infinitely until you hit exit, something like that. The infinite loop, it gets a bad rap, I guess is what I'm saying. There's legitimate reasons to have infinite loops. So important to pay attention. There's a handful of errors you can make when writing code. You can make syntactic errors where you screw up depending on which language you're working on. You don't put a semicolon at the end of a line, for example, if you're playing with JavaScript, or you don't use the proper type of indenting when you're doing Python. Students have no end of trouble when they hop onto like GitHub, copy and paste somebody's code into a Python program and then realize they were using tabs and I was using spaces, and Python doesn't play that game. So they can cause bad problems. Some of them fatal errors, not the kind that end your life, but the kind that end the program. Depending on the language, they may be very forgiving of like how you lay out white spaces. Tabs, spaces, carriage returns, when you hit the enter key. There is actually a language that is exclusively written in white space. It is very clean to look at, however, quite difficult to debug, but a thing you can do. They may or may not care about capitalization, so SQL queries, notoriously, not so fussy about the syntax being upper or lowercase, because it's all going to be uppercase at some point. And then, so like you need to be aware of what the language you're currently playing with, how they treat that. All languages will have some mechanism for you to put in comments. For most bash scripting type stuff, you put a hashtag in front of the line and you make a comment. In some languages, you put a / and then a star to begin a comment and one to underscore it. In Python, we make comments by creating giant string literals. So if you put 3 quotes at the top of a line and 3 quotes at the bottom of a block of text, it'll turn it into a giant comment. Most scripts begin with the shebang or the hashtag and then the bang. That's telling Unix, Linux, Mac OS, any Unix-y operating system that this is going to be an executable script. And like you might have noticed in the one we were looking at here, it's got that shebang and then bin bash, which A says, hey, this is an executable script, and B says, and to execute that script, you're going to use, in the bin folder, the program called bash and Gesundheit. So to run them, if you've got a web script, and always fun to go to your favorite web page and turn on the debugging tools and reload it and see just how many scripts are we talking about on this website. 1, 2, 3, 4, 5, 6, 7. 7 different JavaScript codes executed when I refreshed GitHub there. You kind of think it's just a web page, right? Well, not really. So all of those ran JavaScript, generally speaking, with some asterisks there for like Ajax can talk to web servers and stuff. Generally runs on the client side of the equation here. So it's going to run inside of your web browser. So you're running the code there, and consequently, you can screw with client-side JavaScript till your heart's content. Like you can if somebody's expecting values back from your connection, you can mess with those. Install a copy of Burp Suite and go to town. See all the messing you can do with web servers. So JavaScript tends to be run client-side. On the server side, there are fun and exciting new JavaScript libraries that will run server-side. Node.js is gaining popularity. But still something like 70% of the internet is running PHP under the hood at some point. Fight me. Like in the discussion or in the comments, show me the web page that says PHP's dying again. It always seems to be, I always hear that. That and the year of the Linux desktop. I've been waiting on it for like 20 years now. So on the server side, those are executed, on a web server You make the call to the web server does some code, probably talks to a database, gets data back from the database, and serves up the page. If you're using bash scripts or command scripts or PowerShell scripts, those are going to basically be invoked as if they were a command in the environment. And actually, if you fire up the interpreter for most languages, the same thing holds true. So if you fire up the Python interpreter, you can line by line put code into Python and run it just like a script. So I think this has installed. Yeah, if I just, which Python did I run? 3. Okay, so if the print statements are different between languages, but Python, while in an interpreted mode, will let you just fire up the interpreter and start typing Python commands and have it start running. So same thing's true of command scripts in Windows, where you will have individual Windows commands. Same thing's true of bash scripts in Linux or in ZSH scripts if you're running Mac OS. If there's a shebang, that shebang at the beginning of a file in Linux, most Linux systems, if you have changed the permissions appropriately so that it is executable, and if you harken back to your Linux class, you remember you can chmod things to have a write bit, a read bit, and an execute bit for users, groups, and everyone. If you are given permission to do that, all you should have to do is type, // script name, and that should execute. And then since Windows Microsoft, I should say, acknowledged that people were just using PS1 scripts willy-nilly to break into people's computers, they have, by default, not allowed users to launch PowerShell scripts. And in order to get them working, you have to say it's okay to run PowerShell scripts before they will work. So a little bit of a problem, not much of a problem in order to do that. So that is a security policy that blocks scripts that maybe you don't want things to run. How many of you have ever tried to open an Excel document or something and had Microsoft warn you that, hey, we don't really let people run macros anymore because we had some problems with that in the past? Yeah. So that is, the reason is because we had all these macro viruses running around that would launch when you opened up an Office document, and the next thing you know, you emailed everybody you know with this love letter that said, I love you. So that's no good. So whichever language you happen to be working with, you'll generally have some sort of breakdown of variables and the data you can plug into variables along more or less these lines. So you'll have some sort of integer and some sort of floating point number. Like that. What is the difference between an integer and a floating point? Integers might be
whole number.
Right, counting numbers. You can never execute a loop 3.141596 times. A loop gets executed once, or it gets executed twice. And if you ever take a discrete math course, this is the discreteness we're talking about, right? These numbers are only and only ever whole, as opposed to in calculus land, where everything's on some continuum between 0.000000 almost to infinity 1 and 0.999999 almost, extending on forever, which to my mind is the difference between 0 and 1, but people beg to differ. But so those are for two different use cases of where you'd want to use numbers, right? Sometimes you want to count a thing, and then sometimes you've got to figure out percentages. So floating point numbers and integers tend to be two big divides. Depending on the language, these all fit into memory somewhere. So usually an integer or a floating point number is limited by the number of bits in memory that it is allotted. So usually the size of an integer is some 2 bits, right, 0 and 1, raised to the power of the amount of space the operating system or the programming language that you're working with assigns to those. So if it's 32, 2 to the 32 is some 4 billion-ish number. If they only assign like a byte to an integer or a floating point, you only get 2 to the 8 bytes. And only mathematicians currently graduating from MIT could possibly raise 2 to the 8th power. 4, 8, 16, 32, 64, 128, 5, 12. Oh, that's 1024. Strings are strings of characters. I guess if you've spent enough time around computing, you get comfortable with that. But this could be a string value, this 3.1415. Usually we think of strings as being A, B, C, D, E, F, G, but they are anything represented, depending again on the programming language in question, by anything on the ASCII table is the easy one, or the UTF-8, I guess is probably the most popular. But anything you can feed into one of these crazy ASCII tables will be represented as a string. And what frequently trips people up, so usually that would be like names that you would ask for. Steve, or Bill. And the thing that trips people up is that sometimes you will feed a string into a variable and then try and do math on it or something like that. And depending on the language you're using, can get ugly. And let me just pause to acknowledge the fact that yes, there are strongly typed languages where you have to say, this is a string and only do string things to it, and this is a floating point and you can do math on it. That tends not to be the case with many languages unless you explicitly say, use a strict form of variable typing where you have to assign the types to them as you go. Character tends to be a single one of these string things. And anybody know why we owe a debt to George Boole for Boolean values? Those are either true or false, sometimes represented as 0 or 1, or true or false would be 1 and 0 in most languages parlance. But these are generally like how we evaluate if statements. If A equals 5, that's evaluated to either it's true, A does equal 5, or it's false, A does not equal 5. Or if A is greater than 7, it's true if it's greater than 7 and it's false otherwise. If A is a string, we might have just caused an error there because we didn't bother to type our variables and now we're trying to do math on letters, which works in algebra and other places, but a thing that should be avoided. So sort of the next level of a variable is an array. And this looks like a Python, oh man, Python to the days of the week. And we could get those values back out by doing something like day name is equal to 1. Which value would that return to me? It's okay to be wrong because it's counterintuitive. If I did like print
Tuesday?
Yes, absolutely right. Why not Monday?
Monday would be 0.
Right.
Sorry.
Don't be sorry, you're absolutely correct. So there's only 6 days in the week if you count starting at 0. So that's one of those things that will trip you up in terms of programming and accessing arrays. So oftentimes, another fun thing is like if you use the this is how I did my Fortran final exam, by writing code with a pen, and that's the last class I took at the college that did that to me. But for illustration purposes, if you use the length command, which you can't do in cursive in an IDE, the length will return 7 for that. So if you want to like iterate through that array as a loop, you have to remember to take 1 away from 7 because it is 7 entities long, but each of them will be accessed starting at 0 and going to 6. So These are the things you need to keep straight in your head while you're messing with arrays. You may be surprised to learn that you have a slew of environment variables on your computer, and that you can access them thusly. Do I still have my Windows box? Is that how I get out of Python these days? So in Windows, I think I echo my percent sign path percent sign, and it is a variable built into the environment. So pretty good idea to call it an environment variable. And in the case of the path, this is where the place that we are going to look for programs to run will check. I don't know if I said that as well as I might have wanted to, but so if I go to run dir, it is going to, or Python would have been a more interesting example. Is -v a version? Yeah, nope. Oh, yeah, it is. It did something. Oh, it was verbose. It was running Python in verbose mode. Maybe 2 dashes for version? Nope. -h. It would be interesting to know where that Python is, because it's got to be somewhere in my path variable. And so somewhere in here, I've got like VMware in the path. I've got some Intel garbage in the path, OpenSSH, some Wi-Fi stuff from Intel. Some VS Code is in my path for running an IDE. So it will hunt all of those down. I feel naked. I am without a Linux terminal. Let's log into something.
Oh, it's capital B for version.
Is it? Thank you. So that would have returned which version of Python I'm looking at. So in the same idea in Linux or in OS X would be the $ path variable. And this user doesn't have a ton of stuff in their path, but sbin, user sbin is in there. Similarly, there are other path variables that talk about where the unit's home folder is. That's user profile and home, where you can safely write a temporary file, $temp in Linux, or temp or tmp in Windows, pwd or cd, the current directory or the present working directory, or the current folder that your program is executing in. A thing that we have students struggle with getting their head wrapped around, that programs live inside of a specific place in the file system. And Windows has a couple of extras here. App data is where applications are supposedly safely allowed to store stuff. So if, whoops, that's standard error and standard in. We'll get to that in a second. But if I and use a %sign instead of a $sign, I wind up in, oops, the user DRUR app data roaming folder, which inside of there has a bunch of data for applications that totally interesting and I care a lot about. But a good place to hide applications and a good way to access stuff. The system root may be a little more interesting. It is where the Windows operating system that you're currently using resides. And so my current system lives in C:\Windows on this particular system, but might live elsewhere on different systems. Particularly if you've like installed multiple operating systems over the life of a particular PC, which if you haven't seen the guys go through and install every single version of Windows, starting out with Windows 3, I think they start with Windows 2 and go up to Windows 10, you can upgrade the whole way along. So you'll wind up with a bunch of old directories full of stuff. In Unix, and to a lesser extent in Windows, piping input and output from one program to the next becomes an important and useful thing to get the hang of. So standard in or standard input is a data stream coming into a program. So I don't know if I have a great demo of this handy. What about a log file? If I cat for Etsy, var log dmessage. There's all this stuff going on this server, and it's a big list of text. And cat is the tool you use in Linux to concatenate a file out to the output. That is creating standard output. So standard out is where a program normally sends data, and by default it goes out to the console. And remember, these were things that we kind of came up with when you would have standard output might be a teletype terminal, where it's like actually like typing it out. So often it is useful to take standard output and to pipe that with the pipe symbol, which is next to the backslash, usually above the enter key and below the backspace key on your keyboard, although I'm living that 60% life these days, so that's where it is for me. And you can send the standard output to another program. So you could send it to a program like less, and less lets me look through a large program one thing at a time and move up and down inside of it if I want to review a file. Now, sometimes, like what I just did there is called a dead cat when you're writing a bash script, because really I could have just done less and the var log dmessage. But I was trying to make a point about piping standard input to standard output, or standard output to standard input. You get the idea. You don't need to, like when you bash script, like that's a bad habit to get into, but it's one I've got, so. If one of those doesn't work right, if I cat dmessage this output right there is standard error. And it is the place where an error message goes when something goes awry. So if you write a program like cat, you have standard output, which is where you're going to direct data if everything goes according to plan. You will have standard error, which is where you will direct data if something goes wrong. Right, so that is sending info to standard error. So also a thing you can do. Also a thing you can pipe along, but you can play with that when you start playing with bash scripting. So you can handle both dealing with standard input. You can also capture dealing with standard error as well. A lot of the work you do in scripting will probably involve strings. Like if I really was curious about what's going on in this the log file, I might write a bash script to go through and mess with it. So I might want to read through all of the things in that file, which is generally going to be dealing with a bunch of strings. I might want to cut out particular characters inside of a file. I might want to make them all uppercase or lowercase in order to more efficiently deal with them. In the last time I did the Linux class, one of the things we assigned students to do was find out how many times a given word shows up in the collected works of William Shakespeare, which, if you do it by hand, is going to be frustrating. But you can do it in 3 or 4 commands, not even lines of code, inside of a bash script if you pipe one command to the next, and you know that there is cat, and you know that there is word count, and you know that there is grep. And with using those tools, you can figure out pretty quickly how many times the word forsooth or lo shows up in all of the things Shakespeare wrote, at least the copies that we have on the Gutenberg eText project. Where strings can get really tricky is if you are dealing with languages with which you are not familiar. So every time I have to send a letter to my brother who lives in Germany, I have to figure out how to do that crazy bee-looking thing that's not actually a bee, or like this or something, but it sounds like 2 S's because he lives on a Strasse, it can get complicated. Usually a good idea to have somebody who lives in the language help you out at that point. And then we talked about concatenation, which you can use the cat tool to do to the command line. In programming languages like Python, you can also concatenate strings together if you have a variable named A and a variable named B. If you add them together, if they are integers, you will get some integer value out. If they are strings, you will get a concatenated string. So if A is 1 and B is 2, you will get 1, 2 out of the operation. We call an operator that does that, that does more than one thing, overloaded. So in Python, the plus operator is an overloaded operator. It will do mathematical addition, and it will also do string concatenation, which is a great way to screw up your Python code. Try not to do that. Substitution, sometimes useful. Replacing one string with another value, often useful. Escaped characters trip people up. So sometimes you want to use a character in your code that has already been used by the operating system itself. So if I go back into Python here, just for funsies, let's use Python in verbose mode. And I want to print a quote character. It doesn't work the way I want it to work, actually, because I think I just created a total mess there. But if I want to print that quote, and I don't want to use single ticks, Python coders out there, I have to escape that quote to take away its magical power of completing the set of quotations that are supposed to be surrounding the stuff I'm printing. So if I wanted to, did I just turn on insert? I hate doing that. So if I just want to print the word quote, that's easy enough. But printing the symbol gets me into trouble because there's all this weirdness going on. And I deleted the whole thing. So in order to print that quotation mark, I put a slash in front of it to take away its magical power of closing away that that thing. It's taking away the way the book puts the text, the way that the character is going to be parsed by, in this case, the Python interpreter. Another way that you can protect yourself from those sorts of things, so you can imagine if you're taking code, taking input from a piece of untrusted text, that this can get you into trouble. So usually you want a way to parse that out to deal with it safely. And base64 encoding is a way to do that. And notice we didn't say base64 encrypting, because it's not, although some people mistakenly believe that if I turn something into base64, nobody can read it. Wise to keep that in mind. So in this case, that quote I was playing around with will turn into %22 when I go to base64 encode it. And most operating systems have a base64 encode that you can call on in order to take some blob of text and convert it into base64. So in Linux, that is just base64. And if I'm catting dmessage, and again, this is a dead cat, I'm just illustrating here. It has taken that output and converted it into safer base64 characters, I think. I think I did that right. I might have base64 decoded it. What's base64 do by default? How do I learn about a Linux command I'm not sure about?
-H or man.
I'm in a man code. Yeah, I need a D to decode. Otherwise, it encodes by default. Excuse me. I got to the button in time to mute that one for the second time around. Yeah, so I'm gonna, pro tip on writing bash scripts. Make your friend the man page. So by default, it's taking data and printing, it's base 64 encoding data and printing it to standard output. Now we know what standard output is, and it is encoding or decoding a file. So again, with the dead cat thing, by default. So it took standard in and turned it into this base 64 blob here. And if I really want to, I could take that command, and again, I get it, I'm piping on purpose, to like less. And then I could go through and review all of the base 64 encoded version of my, what was that? The dmessage log file, the list of startup messages. So that's like commands that you run from the command line. When you start stacking them together, you start turning them into a script is probably unfair, but a program that's now got some structure to it and some conditionals and some loops and can do fun things like create functions. And like I mentioned earlier, if you find yourself doing some piece of code more than one time, probably time for a function. So you can say, if we were really into this, we could make a function called base64 encode the dmessage log. And with modern integrated development environments, sometimes it's not a bad idea to do just that, to make your variable names or your function names super long, because it's more important, particularly when we're scripting away and we're not trying to be super efficient C coders who are going to be manually managing the memory on the machine. It's probably more important that the client understand, that the reader understand what's going on with their Python than it is that the person writing the code is like focused on efficiency. So feel free to like let your scripts be long and ugly and have big giant variable names, because it's probably just fine that you do that. Sorry, I digress. So function names, yes, can be long, along with your variable names, because your IDE ultimately will be completing them for you, which is very nice of it. Conditional statements I touched on earlier. So based on a condition, whether that condition is true or whether that condition is false, it will decide to do a thing. And I'd prefer to show you some examples that are open source and available. So I will go to my friends at W3 Schools and do Python, unless somebody's got another language they would prefer to look at these in. These guys are great. But this is how you create a function in Python. The creating functions in another language, very much the same. After you've created the function, you call them thus, and you can pass arguments into them. The nice thing about these guys is they have instructions for Python, for JavaScript, for PHP, and on and on and on and on. So that is an endorsement. I'm a big fan of W3 Schools, and we'll point you at their websites more and more. Same thing with conditional statements inside of Python. So we're going to do something that tests true or false. So in Python, you might have a statement like an if-else. Again, with Python, the spacing counts. So you make an if statement if b is greater than a. Is b greater than a in this particular instance? Feel free to nod.
Yes.
So if b is greater than a, it will print that, right? And the way in Python you know that it will print that is because there are 4 spaces, which I believe is the PEP8 appropriate way to do new spaces. That indentation counts. You will get an error if you don't do it. Thank you they read my mind and already had an example of that. And then this is an if statement with an else statement assigned. Fun fact, the Python operator that tests for equality, which is the wordy programmery way to say the way you figure out if A is equal to B is not a single equal sign. What would happen if I said A equal B as opposed to A equal B?
It would assign A B's value.
Which actually they did up here anyway, but yeah, so the assignment operator, we call that, is the equal symbol. The check is equal to verify that, the comparison operator. So that's ifs, conditional statements. If A is greater than B, if C is greater than D. And then a loop does things for some X number of iterations if you're talking about a for loop, and a while loop, I like to hit that WH sound, is the same deal. And then W3 Schools has my back again here. So the while loop does something while I is less than 6. It's going to iterate. The only time it's okay to make variable names I, or sometimes J if it's embedded, a single letter. So here we've got while starts out equal to 1. They print it, and then the plus equals operator sets I equal to I plus 1. It is a way to cut down on typing. And then it will sit there counting. If you take this I out of here, this line out of here, I will never be greater than 6. So it will sit there and it will count ad infinitum. That is a while loop in its simplest statement. The for loop, a little more challenging, but a useful way to iterate through those lists. I was right. Braces are lists. That's what I thought. A type of array, but a specific type of array. So here we have fruits equal to apple, banana, and cherry, and then for x in fruits, and the x there becomes the apple the first time through the loop, the banana the second time through the loop, and the cherry the next time through the loop. And if I should just hit the try it for yourself button here and let their little helpful IDE execute for me. So when it runs, the first time the loop goes through, it's apple, the next time it's banana, the next time it's cherry. And actually, if you find yourself writing and testing a little bit of Python, let me give you another recommendation for a great free resource I like to use a lot, and that is this Python tutor. And the nice thing about this is it lets you go through and visualize the execution of that. So the little red arrow here tells me where we are in this piece of script. I've got an array, technically a list object, with apples, bananas, and cherries in it. When I get to this for loop, it prints out the first item in the 0th item in the array the first time. I can see Sophia getting ready to jump me on that one. The next time, the 1th item in the array, and now the 2nd item in the array, and so on. The 2th item in the array. Also, nice folks who hang out in their Discord that are willing to help you out with your Python questions if you ever need to. So those are functions, conditionals, and loops. And I kind of talked about comparison operators. So in some languages, equal is overloaded. Those languages scare me. In many languages, equal is the comparison operator between the two things. You can also use greater than, less than or equal to. Did I just flip those two backwards? I think I did. This one, when the alligator is eating the bigger number, or greater than or equal to, goes through and evaluates that. Those are comparing something, and we always get true or false, aka a Boolean value out of those types of evaluations. A logical operator, you take whole math classes on this, are and, ors, and nots. There are truth tables that go along with each one. There are other ones like NAND or exclusive OR comes up a lot if you're going to do cryptography. But the most are is test 1 and test 2 true. So both of them must be true. So if they're both true, it equals true. Or is if one or the other is true. So if that one's 1 and that one's 0, then it equals true. However, if they were both false, it would be false. And not is the opposite of and it flips over the polarity, basically. Reverses your logic. And there's truth tables out there for all of those things if you want breakdowns for all of those things. Friends at Wikipedia have got our back here. So for, oh, and then there's conjunctive and disjunctive ands and ors. Fun reading, not required for the class, but logical true, you've got P and T you're comparing. True and true, false and true, logical false, a value that returns if both are false, the identity, the negation, and then, ooh, all of the truth tables all in one for all the binary operators. Way deeper down that rabbit hole than we need to go for this class, but a fun rabbit hole for you to go down. I invite you to explore it someday. So conditionals, I think we just touched on this, you know, if then else, all those guys, if it's true or if it's false. So do this if it's true, don't do it if it's false, that kind of thing. We looked at for loops, iterating through something. Sometimes you define that control variable yourself. So like while, you know, for A is 1 to 100 or something like that, you iterate through there 100 times. While loops, we looked at a little example code where we did x while y and iterates through. At the end of the loop, it gets to a place where false and it stops. And useful for making your code run well in multiple situations is going through and dealing with error handling. So not the sort of error you make syntactically or logically when writing your code, but usually error handling is to deal with things that are outside of the programmer's control. So like something that goes wrong in the system. So if there's a mistake in reading a file or failing to load a library, those are the kind of errors that we were going to raise exceptions for inside of our code. So we want our code to gracefully handle a problem. So if it can't open the dmessage log file, we should, in Python, you would try and accept. In almost every other language, you try and then you catch. But you want to do something in case the file doesn't open, in case the network socket fails, in case all of those things that are basically outside of the control of the programmer, but things that we would want to find in operation. So that, my friends, is like a super high level 90-mile-an-hour overview of scripting. And you have that exploring a script assignment to do along with the fun stuff in Unit 3, Assignment 3. You ready for a quiz? Pop quiz time?
Sure.
Sure? Feel free to take yourselves off mute. Correct?
Yeah, those already lined up.
Yeah, I feel like that's not much of an assessment. How about now? So is a Windows command prompt a Unix shell? I think those don't work very well. How about, you're not really familiar with the scripting language, but one of the variables was defined as a string data type. What's our best response here? Can be a whole number, can be a fractional number, can be alphanumeric characters, is an ordered set of values, or is defined by the operating system or the scripting language rather than by the script itself. What are we feeling here?
It's either C or E.
Sophia, Tyler, you got a inclination here?
I'm leaning towards C.
Sophia, you can break the tie. We've got 2 C's in it and a half-hearted E.
I think it's C.
Yeah, I'm with you guys. I think C is the one we're looking for. Although it is defined by the operating system or the scripting language rather than the script itself. Well, so I think that would be, I think E is probably talking about things like either reserved words, which would be defined by the scripting language, like print. You can't make a variable. But I guess that would, yeah, that kind of blows the question. Yeah, I don't like E at all. How about this? Which of the following lines would set a variable in a PowerShell script? P.S. The assignment's to look at a PowerShell script. Choose the best response. I guess.
I think it's D.
Yeah, which of these is not like the other? Although I guess you can multiply way by height, but that will probably be easier after you explore a couple of PowerShell scripts, which is in the assignment there. You want to make a bash script named connect scripts executable for all users. Ooh, like Linux plus class history reminder. How do I make scripts executable for all users? I would actually screw this up because I like to use the numbers instead of the letters when I use this. But I did say the word earlier today that is part of the answer here.
I think it's B. I know you do the plus X, but I can't remember if you have to
Yeah, that's
U in front of it or not.
what I was thinking. It's gonna be A.
Yeah.
What if I... How would I find out that? Oop.
I know if you do the plus X, it does make it executable, but seeing as it's specifically set for all users.
The user who owns it is you.
Oh, okay. So it would just be A then.
All right.
Yeah, don't.
All right. What's this business down here?
That is PowerShell.
Right. So that there are like restrictions in PowerShell to not run scripts that haven't been signed, and that's one of them. Again, this is, you want to print an address variable inside of Ruby. Don't really love Ruby, so I couldn't do this one off the top of my head maybe. Which of the following methods will work?
I
Yeah.
haven't been Ruby in a while, so.
I've not touched Ruby.
So fun fact is
Yeah.
how you do the variable thing inside of,
I think it's.
I would do D.
I was gonna say C.
so D looks more like Python to me.
Oh, okay.
C is Ruby syntax, but that one's not really fair until you poke around in some Ruby. Although I suppose you could Google.
I was gonna say I'm thinking of Python.
Yeah, F strings and all that fun stuff. Which characters would you say need to encode an open parenthesis in a URL string? Choose the best response. Would you use to encode an open parenthesis?
I would have to Google a table to figure that out.
Or I bet you if you scrolled back really fast.
Yep. It's the percent 28.
All right. Ding. There you go. I bet you this one works. This is one of those things that gets a little janky. So PowerShell is an else. What's ahead?
I don't think any of these have popped up and worked.
Yeah, they don't. They're not great. But these if else if businesses here. This one works. Like so, these are screwed up. if, else, if, end. How about what is most likely the scripting language below? I got thrown by that one.
PowerShell?
Yeah.
Yeah, I was gonna say that doesn't look like Ruby or Python.
I was thinking, can you do -GE in Bash? And I think no. You want to do a loop in a Python script. All right, I'm feeling comfortable here. Which of the following would be appropriate syntax? Choose the best for, and then which one of those? If you paid really close attention when we were looking at these, there is one character in this for script that gives it away. Put that over there.
Is it D?
Yeah, that's what I was thinking.
Yeah, and it's that guy right there that seals the deal. All right, so this is the end of the first chapter of the material you will find in the textbook, which, if I post these online, highly recommend you buy from our friends at 30 Bird Media. Yes, 30 Bird Media. No. Do I have to put, like, I have to click the advertisement button in this YouTube video now? But we gave you a big overview of all the stuff inside of a pen test, all of the planning pieces, which I believe Sophia wrapped up for us so nicely. How to define scope and engagement and keep yourself from, ideally keep yourself from going to jail, and then a super high level overview of how to look at scripts and think about their structure, which you will have to, really, I feel like programming is one of those things you just have to do and talk about in order to get good at.